Hello, you are most welcome in the online tutorial series from Jeewan Public School. We have initiated to provide you the remote support by providing all the educative videos so that you will be getting maximum benefit while you are residing at your homes. Before I initiate, I'm very much thankful to the students and to the parents who are really supporting the government by residing in their house during this pandemic spread of COVID-19. I do understand that being inside the house is really difficult for one who keeps on engaging in their work, but this is the right time when we can provide our support being a good citizen of our country and also aware citizen. I would like to thank you guys for keeping yourself at your home. In this situation, Jeewan Public School Management decided to facilitate you by providing online tutorials and providing the videos which can be helpful to make you watch again and again on this if you have any doubts on your subject matters. So this is one of the series in that process, and we will keep you post many other videos which will be related to your different subjects. So let's begin with the content what we have here. In our discussion today, we'll be learning about motion, and our learning objectives would be to understand about motion, distinguish between uniform and non-uniform motion using graphical method, to understand displacement, velocity and acceleration, to understand if a physical quantity is a scalar or vector. So these are the discussions which we can have in higher classes as well. As of now, we'll make you understand what quantity can be called as a scalar and vector, and what does it mean when we say if a quantity is a vector quantity. And then we'll be moving forward and explain you if the motion is relative in nature, and then we'll understand the remaining concept based on the numerical and graphical understanding. So now we'll be moving to the other section. So talking about motion, before I initiate on this part, guys, you all know, like if you look nearby yourself or if you look anywhere, you will find either it is living or non-living things, they have their tendency to move. For example, if I talk about living organisms, maybe some animals you can look at, maybe the pet dog, the cat. If you see at your family members, if you see towards the roadside, you will find that many people are moving from one place to another. If you check on the non-living sides, you will find the buses, cars, trains, and maybe some showing their movement from one place to another. So if you look at the nearby surroundings, you will find either there might be two categories where something might be at rest and something might be moving. So the motion forms an integral part of our life. All microscopic and macroscopic objects in the universe show some kind of movement. In everyday life, we see some objects at rest and other in motion. So birds can fly, fish swims, blood flows through veins and arteries, and car moves. Atoms, molecules, planets, stars and galaxies all are in motion. So now look at the video. This video can help you out to visualize those things what we were discussing just now. So in this video we can see there is a movement, either if it is a ball, if it is a car, if it is a toy train, or if it is the kids who are moving in a certain line. But if you look at the visual, you will find the movements might vary. For example, the ball is moving from up and down, the car is moving on a roadside in a straight line, similarly the train is, and depending upon these kids, they are really good kids that they are in a queue. But you can find a boys running in and around, making paths, so there might be movement from one place to another. So with this discussion, now we can decide if it is the time to define what is called motion. So let's see the definition of a motion. An object is said to be in motion if its position changes continuously with respect to a fixed observer or reference point called origin. So in this definition, we have introduced two terms. One is with respect to fixed observer or reference point called origin. We'll discuss this. Just look at the next part. So let us understand with the help of a visual. Now what I'm assuming here is, for example, let's consider the O as an origin and see the zigzag path followed by some. Now we'll be assuming this as a particle A, which is traversing from one position to the other. So if you take the example, we can see if O is a point fixed on a plane, and a given object A moves in a plane so that the position of A keeps on changing with respect to O, then A is said to be in motion with respect to O. So now let us think of a situation. Every morning when we wake up, we find there is a sunrise, an evening there is a sunset, and the season goes on changing. So this is a very common things we observe in our day-to-day life. Common thing which arise in our mind, that is it due to the motion of the earth? And if it is true, then why don't we directly perceive the motion of the earth? We all know the earth is in movement. It goes like if I say it has a revolution, it has a rotation, so somewhere it is moving. Now to understand this, we'll have a look at this video.
Earth and the other planets also undergo motion? Yes, they are revolving around the sun. How can we define something as intuitive as motion of a body? Well, motion. Let's say this vehicle moves from point A to point B. You see that as it's moving towards B, its position in space changes with time. Initially it was here, then here, and now after some time it's here. Notice what's changing. The position of the object and the time too, which is changing anyway.
Now let's just have another example. So this is the example generally we have encountered in our daily life. For example, moving in a train, sitting with your friends, sitting with your family, and then you observe. So with this observation, let you have a look at this video, then we'll talk.
The platform watching the train pass by. You are at rest. For you, both the train as well as the passengers sitting inside are in motion. But will the people sitting inside the train say the same about the other passengers in the train? For a person sitting inside, the people in the train are not moving. They are at rest. So for the observer at rest on the platform, the people inside the train are moving, but for the person sitting inside, they are at rest. What does this tell us? This means that the motion of any object is relative to the observer.
So with this example, this is very much clear. Let's have a look of motion of the train in two ways. One, you are sitting at the platform looking at the train, and in the second scenario, we would be the crew member. We'd be sitting inside the train and we'll be looking towards the platform. So let's discuss for the first point. Being observer sitting at a platform looking at the train. So when you look at the train, you will find the train is moving in one direction, and in the next frame, if you are sitting inside the train and if you look at the platform, you will find that you and your colleagues seems to be at rest, and the platform you will see like if the platform is moving. So it is the same scenario being observed at two places. So if you are trying to relate here, you will find that the motion is relative to the observer, like from where the observer is observing. Here is what we can conclude. An object may appear to be moving for a person and is stationary for some other. For the passenger in a moving train, the roadside trees appear to be moving backwards. A person standing on the roadside perceives the train along with the passenger as moving. However, a passenger inside the train sees his fellow passenger to be at rest. Additional values we can find is motions are complex, like some object may move in a straight line, some others may take a circular path, some may rotate in a few other and may vibrate. There may be a situation involving a combination of this. We'll be discussing into the higher disc. We complete the basic discussion in our video. Alright, let's evaluate our learning so far. So we have two questions here. In case the position of object remains stationary with respect to the origin, then it is said to be at, and the options are motion or rest. Let's check the correct answer. The position of object remains stationary with respect to the origin, and we can say only if it is in motion. We can say an object is moving when its position changes with respect to the origin. So this question answer is the object is in rest. Moving to the next question. Motion is relative in nature. We have to find if it is a true or false. And the answer is true. Alright guys, thanks for watching this session, and we'll be coming with the next videos in which we will discuss the remaining portion of the chapter which were left over, and let's hope for the best. Bye bye.